the topic, monomial times a polynomial. Today is the 19th. And there's just a tiny bit of notes at the top here, and then the rest of it is basically just example after example. And we are going to move pretty quickly today. So if you end up needing some help with the multiplication on this, feel free to use a calculator to do the multiplication. But outside of that, there's not a whole lot. Thank you. Not a whole lot that you might need to use a calculator for today. Maybe a couple problems here or there. But outside of that, some multiplication might be the only thing you need them for today. So here we go. Multiplying a monomial times a polynomial. It says to multiply a monomial and a polynomial, simply distribute the monomial to the polynomial. For exponents, recall the product rule. So we're going to be using the two skills that we're using today are the distributive property and the product rule. And those are two things that we've used quite a bit. And the product rule says that if you have two values that have the same base value or the same variable, then you add the exponents together. So that'd be x to the a plus b. And this is what we just used actually on our tests on Friday. So example 1 says x times x plus 4. So we have a monomial here times a binomial here. And so we're going to take the thing on the outside and use the distributive property to multiply it by both terms on the inside of the parentheses. So x times x, we would use the x or the product rule on this one because we have an x to the first power times an x to the first power, which would give us x to the second power. Add the exponents together. And then 4 times x would be 4x. And that's the answer, x squared plus 4x. Our second example here says 5m to the third power times 3m squared minus m minus 7. So we take our 5m to the third power, multiply it by 3m squared, multiply it by the minus m, multiply it by the negative 7. And that's the distributive property. And then the product rule says we multiply the regular numbers. 5 times 3 is 15. Add together the exponents. 3 plus 2 is 5. So 15m to the fifth. 5 times negative 1 is negative 5. So minus 5. M to the third power times m. 3 plus 1 is m to the fourth power. 5 times negative 7 is negative 35. And there was no m here, so we just bring the m to the third along with it. And that's our answer for example 2. So we're just using the distributive property to multiply by everything on the inside, and then we're using the product rule after that. Multiply the regular numbers, add the exponents that have the same variables, and that's it. So go ahead and get that written down, and then we are going to start going through. I think we'll do every problem because I think we'll be able to move pretty quickly, hopefully, through these examples. So we'll do a few of them together, and then I'm going to set you loose to work on a bunch after that. So moving on down here. Problem number 1. K times K minus 9. Who can tell me what that's going to be? K times K minus 9. What's our answer going to be for that one? K squared minus 9k. Good. K times k is k squared. K times negative 9 is minus 9k. Problem number 2. What do we think about that one? Nine a squared plus 9a. Yep. So 9a times a just a's together, add the exponents, a squared, 9 stays the same, and then anything times 1 is whatever that thing is, so 9a. The 9a squared plus 9a. We'll do 2 more together, and then you'll do 5 through 14 on your own after that. So 3 and 4. Number 3, negative 6p times p to the 4th minus 8. So we're going to start by multiplying negative 6p times p to the 4th. What does that give us? Negative 6p to the 5th. And we're going to take negative 6p and multiply it by negative 8. Negative 6 times negative 8, what does that give us? So negative 6 times negative 8. It's what? It would be a positive, so plus. And I think you need to add 6 more. 48, yeah. So plus 48 p, just p, plus 48p. So negative 6p to the 5th plus 48p on that one there. All right, 4. We'll do this one, and then after that, I'll let you loose to work on 5 through 14. So number 4, thoughts on that one? 3c to the 5th times negative 2c. So again, we're multiplying the regular numbers, and then we're adding the exponents with the same bases. Justin. Negative, yep, 6c to the 6th power, okay. Minus 15c to the 5th, good. So negative 6c to the 6th power minus 15c to the 5th power. 3 times negative 2 is negative 6, c to the 5th times c to the 6th. And then 3 times negative 5 is negative 15. And there wasn't any other variable or exponent here, so we just bring along the c to the 5th after that. All right. I'm not going to give too much time here. Let's say 3 minutes. So at 8:23, we'll start taking a look at 5 through 14. So do as many of the next those problems as you can in the next 3 minutes. And then we will start taking a look at those answers. Okay, so let's start taking a look at these. I've got most of the answers written down through number 14. I don't have 13 and 14 yet, so we can take a look at those together. So starting with number 5, we should have negative 8g to the third minus 28g squared. Number 5, negative 8g to the third minus 28g squared. Number 6, x to the third minus x squared plus 3x. Number 7 should be negative 3n to the third power plus 6n squared minus 24n. Number 8, negative 12x to the sixth power plus 24x to the fifth power minus 36x to the fourth power. If you have questions on any of these, feel free to stop me. If we need to go over any greater detail, please let me know. All right, the next one, number 9, is p to the 7th, q to the 5th, minus p to the 3rd, q to the 4th. Number 10, we've got 3x to the 3rd y plus 3x squared y squared plus 3xy to the 3rd. Any questions so far? Hopefully things are making pretty decent sense. It's distributive property, multiply, and then product rule. All right, number 11. Negative 10 r to the 4th s squared plus 15 r to the 3rd s to the 3rd minus 20 r squared s to the 4th. And then 12, so far I have 12a to the 3rd b minus 21a b to the 4th power. However, there's something about 12 that needs to be adjusted. Any ideas on what that is? Everything else is great so far. And if you leave your answer like this, by the way, this isn't wrong what's written here, but based on what we talked about yesterday with standard form, what could we do here? Or I guess, what should we do here? There we go. Simplify in what way? So if we were to try to add these together, it wouldn't quite work. Even though they have the same variables, they don't have the same exponents. So in terms of like terms, that doesn't really work for us. But what do the total amount of exponents add up to with this one here, the first term? What do the total amount of exponents add up to on the first term here? Four. Yeah, there's 3 here, there's 1 here. What about on this next one? What's it add up to? 5. So we need to go with the greatest total of exponents first when we're writing in standard form. So we're going to switch those around and write negative 21 a b to the 4th power plus 12 a to the 3rd b. And the reason why we do that is because we go first and foremost by, if there is a term that has more exponents than another, it needs to be written first. If the amount of exponents were the same, then we would have written the 12a to the 3rd b first, because the a has more exponents on this one than it does on this one. For example, on numbers 10 and 11, all 3 terms on 10 and all 3 terms on 11 have the same amount of total exponents with each of the terms. But they're in the correct order because the 3 here and then the 2 here and the 1 here with the x, every term here has an exponent total of 4. And so we go with the highest exponent of the first letter first. So that'd be x to the 3rd. Same thing with number 11. These all have a total exponent of 6 on each one of those terms, but the highest exponent with the first letter r is 4, and then 3, and then 2. So we go in descending order there. But because this one here has more exponents with one of the two terms, we write that one first. All right, 13 and 14. Who has an answer for 13 that they'd like to share? Anybody want to volunteer an answer for number 13? And if you haven't worked this one out yet, start by multiplying the regular numbers. -7 times 9. What is -7 times 9? Anybody? -7 times 9. -63. There it is. All right, then add the exponents at the same basis. C to the third, C to the second, 3 plus 2, C to the fifth. D to the second, D to the second, 2 plus 2, D to the fourth. Oops. There we go. -63, C to the fifth, D to the fourth. That's the first term on number 13. And then we're going to multiply -7 times -4. After that, +28, good. So plus 28. And then C to the what? Fourth, good. And D to the seventh. All right, now, looks like there's one more thing to do, which I didn't really leave myself enough room for, but we'll just go over here. And that's because 5 plus 4 is 9 and 4 plus 7 is 11. So this one actually has more exponents in the end. So we're going to write 28, C to the fourth, D to the seventh, minus 63, C to the fifth, D to the fourth. So we'll flip-flop those around to make sure we're in standard form. Highest amount of exponents first, and then it goes down from there. All right. Last one of these, 10 m to the fourth n times -2 m n to the third plus 3n. So start by multiplying 10 times -2. -20, all right. M to the fourth and m would be 4 and 1, so that's m to the fifth. 1 and 3 is n to the fourth. 10 times 3 is 30. M to the fourth, and then n squared. And that one's in standard form because we got 9 here for the exponents and 6 here. So we're in descending order, so we're good to go. All right. Questions on any of those before we move on to doing a little bit more with this idea of multiplying a monomial by a polynomial? All right. Here we go. Number 15. The directions here say to distribute, then simplify the remaining expression. Final answers must be in standard form. So distribute and then simplify. So basically distribute and then look for like terms to combine. So number 15, we're distributing a -2x to a 3x and a -4. So -2 times 3 is -6. X times x is x squared. -2 times -4 is +8 with an x and then plus 7x. So -6x squared plus 8x plus 7x. The 8x and the 7x, those are like terms. We can add those together. 8 plus 7, bless you. 8 plus 7 is 15. So we got -6x squared plus 15x. And that is our answer for number 15. Number 16 is very similar. We distribute twice, though. And there's one thing that you need to pay really close attention to when you distribute into the second set of parentheses. So let's do the first set first. 5w times -7w. 5 times -7 is -35. W times w is w squared. 5 times 3 is 15 with a w, so plus 15w. Now, the thing we need to pay really close attention to on this one is the thing that we are distributing into the second set. What are we distributing into the second set of parentheses? You can tell me that. What's being distributed into the second set of parentheses here? -2w, good. So it's not just a 2w, it is a -2w. And if that helps you to circle the entire term plus the symbol to the left of it. Definitely do that if that's helpful to you, because that needs to be multiplied by a negative 2w. So negative 2 times 13 is negative 26, so minus 26 with a w. Negative 2 times negative 9 is positive 18. W and w squared gives us w to the third power. So we're going to start here with the 18w to the third. And then there's only one term with w squared as well, so minus 35w squared. And then 15 minus 26, those are like terms, they both have a w. 15 minus 26 is negative 11, so minus 11w. So that's our answer for number 16. 18w to the third minus 35w squared minus 11w. All right. That's it for page 1. We're not going to do everything from page 2. I'll pick a few of them that we're going to work on from this next page. So go to page 2. You can see that these are getting a little bit bigger, a little bit more challenging. Let's see. I am going to move us to, let's see, problem. We'll work on problem 19. And 22, 23, and 24. So 19, 22, 23, and 24. Those are the 4 that we'll do. And then we'll do a couple of the geometric ones as well, because I want to take a little bit of time showing you that. So number 19, there's only one thing to distribute on number 19. It's the 2y. So we'll start by multiplying 2y by the 6x and then by the negative 4x squared y. Only one set of parentheses to multiply into. So 2 times 6 is 12. So that would be 12xy. Make sure we're using alphabetical order when we multiply these. And then 2 times negative 4 would be minus 8. X squared and then y squared. Plus 13x squared, y squared. And then minus 6. So the highest amount of exponents are with the x squared, y squared. We have 2 of those terms, so we've got like terms here. Negative 8 plus 13 is positive 5, so that's 5 x squared, y squared. And then the rest of them don't combine because we don't have any more like terms. So positive 12xy, so plus 12xy, and then minus 6. And that's the answer for number 19. So everything that we are doing today, we have done before. We just haven't necessarily put everything together in this way before. But in terms of skills, there isn't necessarily a brand new skill that we're learning today. We're just combining skills we've already done into a new type of problem. All right, 22. Let's look at that one. We have 2 sets of parentheses to multiply into. So we'll do that. So we got 4x squared times 2x squared. 4 times 2 is 8. X squared times x squared is x to the 4th. Let's see, 4 times 1 is 4, so plus 4. X squared times x is x to the 3rd power. And then 4 times negative 5 is negative 20 with an x squared. In the second set of parentheses, we are multiplying a negative x. Make sure you include that negative when you're multiplying it. Negative x times x to the 3rd would be a minus x to the 4th power, or minus 1x to the 4th. Negative 1 times 5 is negative 5. X times x squared is x to the 3rd. Negative 1 times negative 3 is positive 3 with an x. And then, good morning. Got some notes right here. And then negative, let's see, we did that one there. And then plus 17. So plus 17 on the end. All right, then we got to look for some like terms here. And the highest exponent we have is 4. So x to the fourth, 8x to the fourth here. We have a minus x to the fourth here. So 8 minus 1 is 7. So that'll be 7x to the fourth. Then we go to x to the third power. We have a 4x to the third here and a minus 5x to the third here. 4 minus 5 is negative 1. So that would be negative 1x to the third power. For squared, we have a minus 20x squared, and that's it for that one. So minus 20x squared. Regular x's is just a plus 3x. Plus 3x, and then 17 is the only regular number with that. So our answer for 22, 7x to the fourth minus 1x to the third minus 20x squared plus 3x plus 17. All right. Questions on that one? All right, 23 gets a little bit more challenging. And that's because of how it's written here. So the first thing we're going to do, we'll go ahead and distribute everything into the first set of parentheses. There's no problem there. So negative 2 and then r times r to the third would be negative 2r to the fourth. Negative 2 times negative 6 is positive 12. Add the exponents. 2 and 1 is r to the third. And then negative 2 times 6 is negative 12 with an r. So minus 12r. And then we have a plus 4r to the third. And we have another set of parentheses here. Here's my next question. What are we going to distribute into the second set of parentheses? This is what makes this one a little bit challenging. Negative 1. Good. This 4r to the third is not right up against the parentheses, so we will not distribute the 4r to the third. The minus is what's right up against the parentheses, which essentially means it's a negative 1, which is what we will distribute into the second set of parentheses. So that negative 1 gets distributed into the 5r to the fourth plus 10r. Don't forget about, though, we have a plus 4r to the third still. So plus 4r to the third. And then we're going to distribute a negative 1. So negative 1 times 5r to the fourth would just be minus 5r to the fourth. And then negative 1 times 10r would be a minus 10r. So the thing that makes this one trickier is the fact that there's a plus after the first set of parentheses and then just a minus up against the second set. So visually, it makes it a little bit challenging to figure out what has to be distributed. It's the minus, which is a negative 1. Now we can look for like terms. Negative 2r to the fourth minus 5r to the fourth. Negative 2 minus 5 is negative 7. That's negative 7r to the fourth. In terms of r to the third power, we got a couple of those, 12 and 4. 12 plus 4 is 16, so 16 r to the third. I don't see any r squareds anywhere. Nope. And then with r, we have a negative 12 and a negative 10. So negative 12 minus 10 would be negative 22 or minus 22r. Oops. With no regular numbers anywhere. So our answer is right here. Negative 7r to the fourth plus 16r to the third minus 22r. All right. 3 more problems. We're going to do 24, 25, and 26. We are going to do the geometric ones this time. So with number 24, because we have sets of parentheses inside other parentheses, these brackets are just another way of showing parentheses, we have to start from the inside and work our way out. So we're going to start by taking the negative 5 and distributing to the 3ab minus 2b squared. So start from the middle and work your way out. So we're going to start there, which means we're going to have to rewrite this problem a couple of times. So we're going to write pretty small. In fact, I'm just going to write over here. I'm going to say equals, and then that'll be 4b. We're going to keep that, 4b, and then the bracket, and then 2a squared. And then we can do the multiplication. Negative 5 times 3 would be minus 15. And then it's just a regular number, so the variables stay the same, ab, minus 15ab. And then negative 5 times negative 2 is positive 10. And then b squared. And then plus 29 a b squared on the end. So we've gotten rid of the parentheses in the middle. And so we need to look inside this bracket now to see if we can combine any like terms. I don't see any like terms inside the bracket. So we can't add or subtract any of these together. So that means the next thing we need to do is get rid of the bracket. So we have to distribute again. Take the 4b this time and multiply by everything inside the brackets. And when we do that, 4 times 2 is 8. And then we've got the a squared with the b, because we're bringing a b along with it. 4 times negative 15 would be a minus 60. And then a, b and b would be b to the second power, a b squared. And then 4 times 10 is 40, so plus 40. And then b to the second would be b to the third. And we still have this plus 29, a b to the second power on the end. All right. Now, every single one of these terms has total amounts of exponents of 3. So we're going to start with the highest exponent with a, and then go on down from there. So the highest exponent with a is a to the second power. I don't see anything else here with an a to the second power. So the first term is going to be 8, a to the second power b. And then I'm going to look at for a to the first power. We've got a negative 60 a to the first b squared, and then a positive 29 a to the first power b squared. Those are like terms. So we can put negative 60 and 29 together. Negative 60 plus 29 is negative 31. So that would be minus 31 a b squared. And then b to the third power is by itself, so plus 40 b to the third power. And that's our answer right there for number 24. So a few steps on that one. So each of these problems worked a little bit differently depending on how it was written in the first place. All right, last 2 problems. Here we go. 25 and 26. 25 says to find the area of the trapezoid as a simplified expression. Does anybody know the area for a trapezoid formula? Anybody know that one? Looking up on my walls here. Even if I have that anywhere. I don't see it. That's okay. If you saw it, that would have been easier. All right, the formula for the area of a trapezoid is A equals the height of the trapezoid, h, times, in parentheses, the sum of the bases. So we say b1 plus b2. And then that whole thing gets divided by 2. So the height times the sum of the bases divided by 2. And just to identify what those things are in the actual diagram over here, the height is the distance between the 2 lines that are parallel. And so this dotted line, that 4x squared, that's h, that's the height. And then b1 and b2 are the lengths of the parallel sides. So one of these is b1, one of them is b2. It doesn't actually matter which is which. So I'll say b1's up top, and then b2 is down here. So the area of the trapezoid is going to be A equals the height, 4x squared, times, in parentheses, b1, 8x squared plus 3x, plus b2, 2x to the third minus x, all over 2. We've got h times the sum of the bases divided by 2. So first thing we're going to do, we're going to look inside the parentheses here, see if we can combine any like terms. And I see 2 terms that have x. So 3x minus x is 2x. So we can rewrite this as 4x squared. Running out of room here. I'm just going to write this over this way. So 4x squared, parentheses, standard form here would be 2x to the third plus 8x squared. And then 3x minus x is plus 2x. All over 2. All right. Now that we've simplified inside, we've combined like terms inside the parentheses. We're then going to take our 4x squared and distribute to get rid of the parentheses. And then that's going to equal 4 times 2 is 8, so that'll be 8. X squared times x to the third, add the exponents, that's x to the fifth. 4 times 8 is 32. X squared and x squared would be x to the fourth. And then 4 times 2 is 8, and then x squared times x would be x to the third. So 8x to the third plus 8x to the third all over 2. And then the last thing we got to do here is if we divide by 2, every one of the numbers on the numerator has to be divided by 2. Not just one of them, but all 3 numbers on the top have to be divided by 2 to simplify to our final answer. So it's kind of roundabout. I know I'm kind of moving all over the place with this, but I've got some space up this way. So I'm just going to say, all right, here's my answer. 8 divided by 2 is 4. So this will be 4x to the fifth power. 32 divided by 2 is 16. So plus 16x to the fourth power. And then 8 divided by 2 again is 4. So plus 4x to the third power. That's our answer for the area of the trapezoid right over here. So we've got our formula. This formula, by the way, will be useful. If you ever see a trapezoid problem, the area of a trapezoid you now know is right here. Any questions on that one? Okay, last question. Here we go. 26. Find the area of the shaded region as a simplified expression. So the shaded region is the gray part. We just want to find the area of the gray part. Does anybody have any ideas about how to start this problem? Like what has to happen? Like if I want to know just the area of the shaded part, what's going to be a way to figure that out? Killian? Yeah, exactly. It's like if I were to take this piece of paper and cut something out of the middle of it. Just got a rectangle out of the center here. Imagine that's a rectangle. So if I have this rectangle and I want to know the area of whatever's left over, I can take the whole thing and then subtract what I cut out. And so that's exactly what we're dealing with here. So we've got the entire of the overall large rectangle, and then we are cutting out, we're cutting out the white rectangle in the middle, and that'll give us the gray that's left over. So it's going to be the area and then the little s here is standing for shaded. So this means area of shaded equals the area of the large rectangle, that's what the L is, large, minus the area of, I can't use S, I already used S. What should we call that? Oh, how about this? B for big, L for little. Area of big minus area of little. We can just kind of make up the letters as we go. It doesn't really matter. It's just identifying because they all use A because we're talking about area. So we're just using the different letters to say, this is the area of the shaded. That's the gray part. AB is the big rectangle here. AL is the little rectangle in the middle. And so this is the process we're going to use to figure this out. So the shaded area of the shaded is going to equal the area of the big rectangle is what? What's the area of the big rectangle going to equal? How do you find the area of a rectangle? Really? Yeah, just multiply the two sides together. So the area of the big rectangle over here, AB, equals 6x times 8x minus 1. That's the area of the big rectangle. And so if we multiply those together, we're going to distribute the 6x to the 8x and the minus 1. So AB, area of big rectangle, equals 48x squared minus 6x. The area of the little rectangle is going to equal 2x times 5x plus 3. Distribute the 2x. 2 times 5 is 10. With an x and an x is x squared. 2 times 3 is 6. With an x is 6x. So we have the area of the big rectangle. We have the area of the little rectangle. And now we have to subtract the two. And so the area of the shaded is going to be the big rectangle, 48x squared minus 6x. Not leaving myself much room, I apologize for that. Minus 10x squared plus 6x. And I know that's really sloppy. I'm kind of writing on top of what I wrote over there. All right. I'll give myself some more space under here when we write the next step. So that equals. Now, if we're looking at this right here, this looks exactly like what we did yesterday. We're subtracting two polynomials. And so polynomial subtraction, if you're subtracting something that has multiple terms, that thing has to be inside parentheses, which is why I did that. And so we're going to take our negative and distribute it just like we did yesterday. So we have to give that to both of them. So that'll be 48x squared minus 6x minus 10x squared minus 6x again. So we distribute that negative. Polynomial subtraction, just like what we did yesterday. And then we combine our like terms. 48x squared minus 10x squared. 48 minus 10 is 38. And then negative 6 minus 6 is negative 12. All right, so that gives us our answer, 38x squared minus 12x. All right, there were a lot of different types of problems there today, but I just want to remind you all again, not any individual step there wasn't new. There were no brand new individual skills that we learned today. It was a combination of things that we've already learned. We're just putting them together in a new way. So the best advice I can give you is just do one step at a time. If you look at the problem and you try to solve it all just by looking at the problem, it can quickly become overwhelming. So my recommendation is find one thing you can do to start the problem, and then look for one thing to do after that, and keep looking for one thing to do until you can't do anything else. And usually when that happens, you're at the end of the problem. So your assignment's coming around. This is one side of the paper again today, so it's not a two-sided. We've got about 12 minutes left, so get started on this. And as you're working on it, if you have any questions, let me know.